During this clash, U.S. sensors logged something both shocking and telling. The Z-10's communications encryption was traced back to 2003, and its radar frequencies hadn't been updated since China first bought Russian designs. In other words, every aggressive maneuver only revealed just how outdated the machine was. Imagine broadcasting your playbook to your rival in real time. That's what Beijing accidentally allowed to happen. In a single standoff, the U.S. collected years' worth of intelligence that will shape how future missiles and countermeasures are designed. Before we move on, please take a moment to subscribe to the channel and like the video. What happens when a helicopter built with Russian guidance from the 1990s tries to throw its weight around against the U.S. Navy in 2023? That was the question on full display as a Chinese Z-10 closed in on an American MH-60R Seahawk operating over international waters. The distance between them shrank until they were only about 500 meters apart, and the Chinese helicopter wasted no time in broadcasting warnings. As it banked hard to the left and rolled back across the Seahawk's nose, the intent was obvious: create a sense of danger, flex presence, and push the U.S. aircraft toward disengagement. The scene looked tense, but underneath the appearances, there was a very different contest underway. The MH-60R remained steady on course, its crew watching the maneuvers with calm professionalism. Aggressive moves may play well for political signaling, but an experienced crew recognizes what matters most isn't showmanship. It's systems, sensors, and what gets revealed in the heat of posturing. And with the Z-10, almost everything was being revealed. Its design roots were immediately recognizable. The radar sweep pattern had the unmistakable rhythm of hardware that had not seen meaningful upgrades in decades, and the communications channel it used still carried the distinct footprint of early 2000s encryption methods. This meant that while the Chinese pilot thought he was imposing on the Seahawk, his aircraft was basically shouting out its vulnerabilities in real time. U.S. forces had no trouble categorizing the radar emissions and matching them instantly with older libraries of signals intelligence. Encryption, that might have once provided secure comms between Chinese platforms, now stood out as primitive when compared with modern standards. To U.S. operators, it was the equivalent of watching someone turn on a flip phone in the age of smartphones. It worked, but it was transparent and predictable. While this played out in the air, the Seahawk was far from alone. Just out of sight, an EA-18G Growler was orbiting with its own agenda. Every spin of the Z-10's rotors generated a distinct harmonic signature, and the Growler wasted no time in capturing it. Comm bursts from the helicopter, the frequency ranges used by its data link, and the radar pulses meant to track targets were all being recorded. Piece by piece, the U.S. was building a detailed technical profile. Far from retreating, the American aircraft were harvesting information that engineers back home could use to tailor countermeasures, refine jamming protocols, and understand stress points in Chinese aviation hardware. What made the situation telling was the mismatch between words and reality. The Z-10 sprayed verbal warnings across the airwaves, demanding the Seahawk adjust course. Yet every passing minute, the Americans were the ones calling the shots, not by responding, but by digging deeper into the signals pouring out of the helicopter. The louder the threats became, the richer the intelligence haul grew. What began as an attempted intimidation run turned into a lengthy exposure. The face-off lasted 72 minutes. That is more than an hour of non-stop access to rotor data, voice comms, and emissions across the entire operating spectrum of the Z-10. Instead of pushing out an American crew, the Chinese helicopter opened itself like a case file. Every aggressive maneuver was logged, every radar sweep captured, every strained transmission evaluated. From the U.S. perspective, this was a windfall. Instead of deterrence, they walked away with fresh insights into weaknesses that could now be exploited in future confrontations. Of course, the contest wasn't only about passive collection. Everything so far had happened without any real contest of electronic strength. That changed when jamming entered the fight, a shift that showed just how fragile the Z-10 truly was once modern electronic warfare was applied to the battlefield. Imagine sitting in the cockpit of a combat helicopter and seeing a single target on your radar screen. Then, within seconds, that single blip turns into 12. For the Chinese pilot inside the Z-10, that wasn't imagination, it was reality. What had begun as a controlled intercept suddenly broke apart into chaos when a U.S. EA-18G Growler entered the confrontation and switched on its ALQ-99 jamming pods. The Chinese crew had no idea how quickly their picture of the battlefield was about to collapse. From the moment the Growler powered up its jammers, the Z-10's fire control radar started showing distortions. At first, it looked like extra clutter, but within moments the entire display became difficult to read. Phantom shapes appeared and multiplied across the screen. To the pilot, it looked like the Seahawk was suddenly joined by an entire flight of aircraft. The lines blurred, targets moved erratically, and the radar refused to provide a clean lock. What should have been a simple track dissolved into something that felt like broken television reception from the analog era, when twisting the antenna made the picture shift and collapse. The Z-10 tried to press its advantage, but its own systems were buckling. The pilot suddenly faced warning lights flashing across the cockpit. Hydraulic alarms sounded as pressure levels began to fluctuate. The aircraft's avionics were being overloaded by signals it had no ability to filter or counter. Even worse, transmission temperatures began to rise above tolerance, forcing the crew to throttle back cooling systems to prevent an overheat. As the mission dragged on, the controls began to feel heavy and slow to respond. The machine had been designed for basic engagements, not for operating under the stress of a sophisticated electronic attack. Desperation drove the crew to reassert some control. They attempted to switch from radar-guided locks to laser targeting, hoping to bypass the flood of ghost returns. For a moment, a green laser crosshair narrowed in on the Seahawk's position, but the Growler's jamming was frequency hopping so quickly that every fresh lock disappeared almost as soon as it began. None of the Z-10's targeting systems could maintain a track for more than a fraction of a second. Each failure added to the pilot's frustration, and each attempt gave American operators more insight into the helicopter's radio spectrum, laser frequencies, and fail-safes. What the Chinese crew didn't realize was that every move provided another data point to their opponent. Engineers near the Growler were recording not just the radar distortions, but the exact frequencies the Z-10 attempted to shift across to re-establish its lock. They noted the heat spikes in the engine, correlating them to bursts of power as the pilot pushed the aircraft harder to keep up. They marked down the moment sluggish controls revealed how long the hydraulic system could endure under electronic stress. Actions meant as counters became giveaways, turning the helicopter into a test model without the crew ever consenting. By the time the jamming cycle reached its peak, the Z-10 could barely function in the air combat role. The inability to sift through false targets meant that its offensive capabilities had evaporated in less than 10 minutes of electronic pressure. What might have been tolerable for a brief skirmish now revealed a fatal limitation. The platform was not built to function beyond a short window of interference. Structurally, it was sound enough to keep flying, but tactically it was blind. The standoff proved something larger than a single encounter. China's attempt to signal strength showed how modern electronic warfare can unravel an outdated platform. Instead of intimidating its opponent, the Z-10 exposed its limits, offering the U.S. valuable intelligence in the process. Every maneuver showed where technology fell short under pressure. The lesson is clear. Posturing without deep capability risks doing more harm than good. In the 21st century, real dominance may not come from visible firepower, but from invisible control of the spectrum. Thinking about how electronic warfare quietly shapes tomorrow's battles is no longer optional. It's critical.